All right, welcome. Think of this as a special mission. We're about to become mathematical code breakers. And our target? The secrets hidden inside of cubes and cube roots. It's all about spotting patterns. And trust me, by the end of this, you'll be able to crack any code these numbers throw at you. Let's dive in.
So let's start with a puzzle. What exactly makes a number a perfect cube? We're not talking about just any old number. We're looking for one that has this perfect, orderly structure hidden deep inside. It's like a perfectly balanced, elegant piece of code.
Okay, so before we can crack any codes, we've got to know the language, right? A cube is just a number multiplied by itself 3 times, raised to the power of 3. So if you take 5 and cube it, it's 5 times 5 times 5, which gives you 125. That's the basic move.
Now for our first real code-breaking tool. And here's the best part. You don't need some super fancy calculator for this. All you need is this cool method using something called prime factorization. We're going to call it the triplet test. This is our secret key.
So how does this work? It's actually pretty simple. And here's the big aha moment. When you cube a number, let's say 6, you're really cubing its prime factors, which are 2 and 3. So 6 cubed is just 2 times 3 times 2 times 3 times 2 times 3. See what happens? You naturally get a group of 3 2s and a group of 3 3s. So our test is just looking for that signature. Can we bundle all the prime factors into neat little groups of 3? If we can, bingo! The code is perfect.
All right, time to put it to the test. Let's run our first diagnostic on the number 216. Is it one of these perfect numbers? Let's fire up the triplet test and see what's hiding under the hood.
So we start breaking 216 down. And look at this. What do we find? We get 3 2s and 3 3s. They form 2 perfect, complete triplets. No leftovers, no stragglers.
And there you have it, a perfect match. Because every single prime factor is part of a complete triplet, the code is solid. 216 is a perfect cube. And we can even see it's 6 cubed because it's made from one group of 2s and one group of 3s. 2 times 3 is 6.
Okay, so that one was super clean, right? But what happens when the code isn't so perfect? Let's run the exact same test, but this time on the number 297, and see what we get.
We start the process on 297, and we find a nice triplet of 3s, which, is a good start. But then, we've got this single factor of 11 just hanging out by itself.
And that's it. That's our answer. That 11 is all on its own, a real lone wolf. It doesn't have a triplet to join. And because of that one single leftover factor, the code is broken. 297 is not a perfect cube. Simple as that.
Okay, so a number isn't perfect. Is it just a lost cause? Nope. And this is where it gets really cool. We can actually fix the code. We can figure out exactly what's missing or what needs to be removed to make that number perfect.
Let's try a little repair job, shall we? Our patient is the number 3087. We know it's not a perfect cube right now, but we're going to make it one. The only question is, what's the smallest tool, the smallest number we need to do the job?
Okay, let's look under the hood. When we break it down, we find a perfect triplet of 7s. Fantastic. But wait, look at the 3s. There are only 2 of them. That triplet is incomplete. It's missing a partner.
So what's the missing piece? It's pretty obvious, right? To complete that set, we just need one more 3. So if we multiply 3870 by 3, that lonely pair of 3s becomes a full triplet, and the whole number becomes a perfect cube. The missing piece of the code was just 3.
And you know what? This whole code-fixing thing works in reverse, too. It's like 2 sides of the same coin. Instead of adding what's missing, we can just remove what doesn't belong. Take a number like 6,750. It's got this single leftover 2 in its factors. So to make it perfect, we just divide the whole number by 2 and get rid of it. All right, so we can spot perfect cubes. We can even build them. It's time to level up to the final boss, reversing the whole process. This is what we call finding the cube root.
So what is a cube root? It's really just the answer to the question, hey, what number did we start with? If we know that 3 cubed is 27, then it's just common sense that the cube root of 27 has to be 3. We're just going backwards.
Let's take a big number, like 1728, and use our trusty triplet test to work backwards and find its original building block, its cube root.
You know the drill by now. First step is always the same. We break it all the way down into its prime factors. And when we do that with 1728, look at that! This beautiful orderly structure appears. We've got 2 groups of 2s and 1 group of 3s.
Okay, now that we have all the building blocks laid out, the next part is actually, well, it's surprisingly easy. First, we just formally identify those complete triplets. We see a triplet of 2s here, another one here, and a triplet of 3s over there.
Now here's the secret move. From each of those complete triplets, we only pull out one representative, just one. So we'll take a single 2 from the first group, another 2 from the second group, and 1 3 from that last group.
And for the grand finale, we just multiply those representatives we pulled out. So what do we get? We got a 2, another 2, and a 3. Let's see, 2 times 2 is 4, and 4 times 3 is 12. And that's it. The cube root of 1728 is 12. The code is cracked.
Okay, you have absolutely nailed the main technique. So to complete your code-breaking training, let's wrap this up with a quick masterclass on a couple of special cases you might run into out there.
The rules here are really straightforward. First up, negative numbers. This is super easy. The negative sign just kind of hangs out and comes along for the ride. The cube root of -8 is just -2. And what about fractions? Even easier, believe it or not. You just treat it as 2 separate little puzzles. Find the cube root of the top number, and then find the cube root of the bottom. Done.
And just like that, you've cracked the code. You're a master of cubes and cube roots. But the big takeaway here isn't just about cubes. It's that all of mathematics is filled with these amazing, beautiful patterns, just waiting for a curious mind to come along and figure them out. The only real question is, what puzzle are you going to solve next?